I want to introduce our second and final technique for change of basis with this example. This is actually example one from the textbook, stolen straight from Lay. Okay, so let's take a look at this. You've got two different bases. This time they're not even telling you what they are. They're just saying the first one is B1, B2, and the second one's C1, C2 without numbers attached to them. However, what they do tell you is essentially the C coordinates of the first basis vector in B. They say whatever that first basis vector is in B, you can get there by doing 4 of C1 and 1 of C2. And same thing for the second basis vector. Then they also say, hey, the place we're trying to get, X, and then they give you some B coordinates for it. You say 3 of B1 and 1 of B2. So the B coordinates for X are 3, 1. And they just want the C coordinates of X. And they don't really actually ask you for the change of basis matrix. So I'm going to extend this example a little bit and get the change of basis matrix so we can do it for all B coordinates, not just 3, 1. But for the moment, let's start with that. So keep in mind that 3, 1 means 3 times the B1 vector, whatever that is, plus 1 times the B2 vector, whatever that is. And if we want to rewrite that in C coordinates, let's just start by saying I know that B1 can be replaced by some C stuff. So wherever I have that B1 written, I should be able to replace that with 4 times C1 plus C2. And wherever I see B2, I should be able to replace that with negative 6 C1 plus C2. These C's are still vectors. I'm just going to put little brackets around them because I'm obsessive that way. Okay. Anyway, I've just replaced B1 with what they told me it was equal to. And now I'm going to distribute and collect like terms a little bit. So let's see, I'm going to have 3 times 4, which is 12, but I'm not going to multiply it out. Okay, so C1, maybe I'll drop the brackets now. Plus 3, C2, plus 1 times negative 6. I should use parentheses. 1 times negative 6. C1 plus 1 times C2, and I am going to collect like terms here. So my C1 is going to be 3 times 4 plus 1 times negative 6, all that. This times C1. Numerically, there's nothing wrong with turning this into 12 minus 6 is 6. 6 of C1, but I'm going to leave it written out like this. And same thing, C2 is just going to be 3 and 1, 4 C2, but I'm going to keep that as 3 plus 1. And notice what I figured out here is I have taken my B coordinates of 3, 1, and I've turned them into C coordinates. That's what I have written here is some number times C1 plus some other numbers times C2. The actual coordinates happen to be 6, I already crunched that one down, and 4. So really I could stop right there and say the C coordinates are 6, 4. But I want to squeeze a little bit more meaning out of this example. So let's go on and get that change of basis matrix that would tell us how to do this always, not just for 3, 1. Matter of fact, let's kind of rewrite. Let me get messy here. I'm just going to write on top. I'm going to replace the 3 with A and the 1 with B. So just say generic. So suppose the coordinates had been A B instead of 3, 1. Okay, so let's redo this. Replace that with A, that with B. So that becomes A, B, B. That becomes A, and that was a B. And this was an A, and that was a B. And I want to point out that we're just trying to calculate, that number right there and that number right there. Those are the C coordinates, and I can rewrite this as a matrix multiplication, something times AB, right? That's really what I want, is how to take B coordinates, multiply them through some matrix, and get C coordinates as a result. So the multiplications that I need here, I need A to get multiplied by 4 and 1, and B by -6 and 1. Check this out. When you multiply now, you get 4A minus 6B, and that's the first C coordinate. And then again on the bottom you get A plus B, which is the second C coordinate. So notice what this change of basis matrix ended up being. It ended up being the C coordinates of B1 and the C coordinates of B2. They sort of had them written out this way, but really we would write those 4, 1. Oops, and -6, 1. So putting those together gives you your change of basis matrix. So if you have B1 in C coordinates, which we did, that was our 4, 1. We said that's how to write B1 in terms of the C basis. And you also have B2, same thing for the other basis, B2 in terms of C coordinates. Then the change of basis matrix from B to C is these two things, right? Is the B1 in terms of C and the B2 in terms of C. This actually gives us like a third way to find the change of basis coordinates matrix. For our previous example, we could have also in that previous example figured out the coordinates of each B1 vector in terms of C, and that would have been the change of basis matrix right there. That's all we would have needed. So 3 different ways to get your change of basis matrix if you know all the numbers. If you don't know all the numbers, if they give you something more theoretical like this, then of course you have to go this way without actually ever knowing the B vectors or the C vectors. Okay, I think with that you are ready to tackle the homework, and you've pretty much seen examples of all of the homework types, so I think I'm not going to do an examples video this time. I'll just let you tackle it, and if it goes horribly, let me know and I'll make some example videos for you.